All right, heading down the home stretch here of Unit 3. Zeros of polynomial functions. Now, the main reason that we're going to show you how to do some of this with possible rational zeros at the top is to kind of, at least to me, show you how fortunate you are to have calculators now. Because I remember doing this back when I had to do this way back in the ancient days. And I'll show you how we would have had to deal with it without a calculator to help us get started with zeros. But for now, let's just kind of keep ourselves on the up and up here. Okay, the rational zero theorem. If we're going to talk about it in foreign language, in mathism, if p of x is a polynomial function with integral coefficients, then every rational zero at p of x equals 0 is of the form p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. Okay, let's decipher this into English. All of your zeros of a function must come from all the factors of your constant term, a fancy way of saying the number on the end that doesn't have a variable. For instance, in example A, my constant term would be 10. Well, positive, negative. We'll get into that part in a minute. Over all of the factors of my lead coefficient. So whatever my coefficient is in front of my first term, as long as they're in their correct degree order. So, when it asks you to list all the possible rational zeros of each function, what you technically have to do then is say, okay, here, my p-value would be this negative 10, and my q-value would be 3. Negative 10 being my constant, 3 being my lead coefficient. And my job then would be to write down every possible factor of that number. So even though they've got some of it down here, so like for instance with the 10, I'd have positive and negative 10. 5's a factor. 2's a factor. 1's a factor. Anything that's divisible into that value could be a possible factor of it. So every single one of these would have a plus minus. Now luckily with the 3, there's not as many. It's basically 1 and itself. But then comes the fun part. To figure out what could possibly be a 0, possibly be an x-intercept of these, you have to create the fraction p over q. So you would go through, back in the old days, and you would do every combination possible of these division. So 10 divided by 1, 10 divided by negative 1, negative 10 divided by 1, negative 10 divided by negative 1, 5 divided by 1, 5 divided by negative 1. And you would make like 8 bazillion choices. Like there's 2, 4, 6, 8, 10, 12, 14. There's like 16 possible rational zeros. And before, what you would have to do is you would have to guess one of them randomly. You'd do synthetic division. If you got a divisor of 0, great, that's one of them. If you didn't, you go, oh darn, and you try the next one. So there's possibly that you would have to do 16 synthetic divisions in a problem. Now, who wants to do that? Nobody. I had to, but again, you don't want to do this. So what are we going to do? Well, now that I've shown you that just wonderful old way of doing it, which we're not going to do, instead, we are going to be smart because we are technologically advanced and not living in the Stone Age. And we are going to use our calculators to deal with this. You're like, so why did you just show us that? Because sometimes you need a reality check on how fortunate we are. So let's see here. Because when they, even in the book, we're talking about making you do this, I'm like, are you serious? That's just not smart. So we're going to go back to what we were doing before. We're like, okay, we know, now I'm going to bring this down for a minute. This will be the only part that I'm going to make you do that's painful now that I think about it. When it says list all possible rational zeros, again, I want you to feel the love of having to do this. I'm not going to make you do it for number 1, though, because what do you notice about example 1? It's the same as this. So we're going to be smart Alex. See example A above. Okay, that one's done. Number 2, I don't know what I was thinking when I did that. Must have been a little too cut and paste happy. So when I get to this next one, we're actually going to find, now, possible. We're not going to go through and do all the synthetic division. So what we need to do here is, okay, we're going to write down our P and our Q values. So for instance, my P value would be the negative 36, and I better move this Q down because I'm going to need some room. My Q value, my coefficient of my lead term is 1. So again, if this were back in the day, you're like, you really want me to write down plus and minus every factor of 36? Yes, because that's how we used to do it before we got smart. So you're like, so plus and minus 1, let's see, plus and minus 2, oh my gosh, 3, 4 goes into 36. Hardy, couldn't you have picked like a prime number? Yeah, I know. 6, 9, 12 goes in, 18 goes in. Just think about how lovely this would be if you were trying to figure out which of these were actually going to plug in there and work. And then, of course, there's Q, which is positive and negative 1. So you're like, well, wait a minute. Positive and negative 1. Isn't P divided by Q then? If I do all of these out like you did here, with it just being plus and minus 1, isn't it just the P stuff all over again? Mm-hmm. So we're just going to call it, you know, look up here at the P list. We're actually going to get to do this on one of them, but if it's just 1, why are you going to rewrite all of that stuff again? That's just busy work. We don't have time for busy work. We have like real stuff to do. But if you're asked to find rational zeros, that's what we're doing. So just to make sure here, on number 3, what would my P value be? Which one's my constant term? Negative 5. Okay. And then what's my Q going to be? 2. So all I'm going to do is I'm going to write down possible factors. And 1 is going to be included in everything. And so is the term itself. But luckily this time there's no other terms because they're both prime. So when I'm actually looking for the zeros, which is P divided by Q, I'm taking each combination. Now here's how I would do it. Okay, my P is plus and minus 1. When I do it plus and minus 1, 1 divided by 1 is 1, negative 1 divided by negative 1 is 1. It's all the same. But then the 2's would be plus or minus 1/2. But again, I cover everything using those, because if I did positive 1 divided by positive 2, I'd get positive 1/2. If I did both negatives, I'd get positive 1/2. But if I did 1 positive and 1 negative, I'd get the negative. So it's not like I need to write it out 4 times for each of these. 5 divided by 1 would get me 5, so plus and minus 5. And then 5 over 2, again, I would just do with plus or minus. Those would be my possibilities of what my solutions or what my zeros would be. Even though I know for sure there's only going to be 4 answers, and I have 8 here, and I may even have some that are imaginary. But that's, again, what we used to have to do. It's like, that's awful, Hardy. It is. Now, again, this would be necessary for me to remember if I was going to do this craziness with all of the synthetic division. But again, we're too smart for that. So we're going to see if we can shortcut this at all. And if we can, like we did in the last section, that's exactly what we're going to do with this. So if I look at this one graphically, I'm like, bummer. I know there's going to be 3 solutions. I physically see 1. Now, what is that 1? I could either use my second trace and use the 0, or if I'm lucky, maybe I just find it in my chart, because that would be an x-intercept where y equals 0. So I can get x equals -3 from the graph or from the table. That's the easiest way to go. Because like I said, back before we were playing with graphing calculators, this would be the point where I'd start guessing numbers until I would hope to find one that would work. So once I get that first one, we're going to keep life simple. We are going to use synthetic division, but we're not really guessing. We know this is going to work. And again, I know it works by the fact that it's not going to have a remainder. That's how I always make sure I'm doing things right with these. So no remainder is always a good sign. You're like, oh, so this is going to be a lot like 6, 7, except I had to do that thing so Hardy could feel better about his youth 20 years ago. Yes, so I started with a degree of 3. So I come down 1 from that. And since I'm now down to a quadratic, which is the magic form, I originally would try to factor this to see if I can get my other two values. If it's not factorable, and this one's not, then I go ahead and I use the quadratic formula to get my other two solutions. So again, I've got my -b, because here's my b value. So the opposite of that would be 2, plus or minus the square root of b squared. Remember the parentheses. You never should get a negative number out of your b squared term. Minus 4ac all over 2a. And we're just going to clean this up. So let's see here. 4 minus 20 would be -16. And now comes the one thing I have to remember when I'm dealing with the radicals. I must remember to pull my I out. So once I pull the I out, the square root of 16 itself is 4. Don't stop. If you have a common factor between all three terms, take it out. They're all divisible by 2. I could put this over 1, but I really don't have to. So there's 1 solution, 2 solution, 3 solutions. I've got it. So basically what I'm telling you here is this unit, this section, is basically going to run like 6, 7 was, except occasionally you're going to have to find the different pairs of rational zeros. So let's just do one more here, just to clean things up, make sure things are okay. All right, let's see. It looks like we're going to get 2 real ones this time. And my 2 real zeros look to be at -2 and 3. Okay, so I got those from the graph. Again, it doesn't matter when I go to do my synthetic division for the other solutions which one I use first or however this is going to work. I'm going to end up using them both. So let's just say I use the -2 first. No holes. I always want to check for that, because if there's a hole and I forget it, and we've seen me do that before, that can happen. So once I get rolling, and again, I'm just multiplying, adding down. Multiplying and adding down. But here again, this is the part that lets me know I'm going to have to do my synthetic division more than once. I started with a 4th degree polynomial, which means this is going to be a 3rd degree polynomial. But until I get to a quadratic, until I get something that's x squared, I have to keep using synthetic division. So here, I used the -2 already, so now I'll use the 3. But again, I'm using the one that I just got done calculating. Don't go back to the original. That could get you in trouble. So I'm going to multiply and add, multiply, add, multiply, and add. And again, I'm getting zeros for remainders, which is good. That tells me these are actually factors. They're zeros. Since I started this time with a 3rd degree, now I'm to x squared, which is good. Again, I look, I try to factor it. Bummer, can't factor it. So my final 2 answers are going to come via the quadratic formula. So again, -b plus or minus the square root of b squared minus 4ac all over 2a, or just plain old 2, because 2 times 1 is 2 anyway. So we've got 4 minus 8, well, heck, -4. And similarly to what happened in number 4, with that negative, I'm going to have to pull an I out, and then I'll have the square root of 4, which is 2. And they're all divisible by 2. And again, I could put the over 1, but I don't have to. Not a big deal. And again, there are going to be some times, as we get ready to flip over here, I'm going to jump to number 7, and then we're just going to do that one app problem at the bottom, and we'll have you ready to go here. That if you get fortunate enough, and don't think something's gone wrong or you have to change something, if you're fortunate enough that you get to a problem like number 7, and just maybe you can get all of your zeros straight from the calculator, there is no need to recreate something that works fairly easy. So I'm like 1, 2, 3, 4. I'm supposed to have 4 answers. If they're all nice numbers, that'd be even better. Oh, and they are. Because everywhere the y value is 0, that x value is one of my zeros, or a solution. So -3, I see a y equals 0, -1, 1, and 2. 4 answers, all from the graph. You're done. Go to the next one. Don't make life difficult. I want you to be problem solvers. Problem solving is not having to take 16 different possible rational zeros and plug them in. It's goofy. Okay. Last thing. All right. Devon made a box with length x plus 1, x plus 3, and height x minus 3. What is the volume of Devon's box as a function of x? In other words, what is x minus 3 times x plus 3 times x plus 1? Because that's going to give it to me as a function. I don't know what x is yet. So I'm going to multiply each of these out. So if I take them a pair at a time, which is what I'd suggest doing. So let's see here. X squared plus 3x and minus 3x will cancel. So I've got x squared minus 9. And I'm going to times that by my remaining binomial term. And again, if you use a box, that's fine. If you do just straight FOIL here, that's okay. I'm good with any of it. So as a function of x, that would be what the volume of Devon's box is. So what is x if the volume of the box is equal to 1,001 cubic inches? Well, this is the volume, So I could take that and if I wanted to use it like I've been using on some of mine, I'd go ahead and I'd bring this over to my polynomial side by subtracting it. And then hopefully when I go to the calculator, I'm not going to have to sit and figure out all the common factors of 1,010. Holy cow. I'd only have to give you one problem for homework and that'd even be too much. So, let's see if we can find a 0 that is going to be sensible. I see something going on over here. Wait a minute. Let's go check this out. Let's make our x max 20 here and see if we get some more. Oh. What value are you? You are 10. Okay. X equals 10. Now, here's what that tells me. Since I only saw on the graph, I saw one actual real solution. It means if I went through and did synthetic division, since this is a cubic, I'm going to get 2 more answers, but they're both going to be imaginary. So actually, this then, since it's my one real answer, would be the solution. Now if I'd add negative and positive answers, of course x wouldn't be negative, then it's a negative side. What sense does a negative side make? So they're just asking for what x is. You don't have to find the sides of the box, you don't have to prove it equals 1,001, just find x, be done. What is x if the volume of the box is equal to 14 5/8 cubic inches? Lovely. So basically we're doing the same thing, except now I'm even going to a decimal on this. 5/8 as a decimal is 0.625. I'm still going to subtract it over. And just like we did on the last one, we are going to, I didn't declare that all out. Now I'm going to hope here again that I get some real, right there. I'm going to get back to my standard zoom here just a second. All right. Do I get a nice one or do I have to go looking for it? Looks like I have to go looking for it. Now it doesn't mean just because I go through here and I don't see a y equals 0, it doesn't mean that they're all imaginary. What it means is this isn't going to be a whole number in this case. So if it's not, I always can do my second trace and go find the 0. It just may take me a second. Keep watching those y values. Hey, there he is. So since we're coming in from the bottom, we'll click first below and then we'll click the second time above for our left and our right. So 1 below and we'll click above and it looks like it is 3.5 would be my x value, which still can make sense even though the height of my box isn't going to be very tall. But that's all I'm doing here. So here's how this will work here for us for the basically going towards the end of the week here. This will go in homework check 13. If I am using my brain properly, yes, this would be assignment number 3. So basically what we're looking at, do I want to do that? Nah. Is that we've got this working here. Tomorrow will be quiz 10, which I'm assuming isn't going to take the whole hour. So tomorrow we're also, and that's incorrect on the exponent practice because that'll be assignment number 4. But since exponents seem to keep coming up as an issue on things, we're going to get a little more practice in with that post-quiz. So that'll end up being number 4, and that'll be the last assignment tomorrow for the next homework check. Which, well, I see right now on the board I have it as way too far away. It says next Wednesday. That's not happening. So let's see. Thursday will be the last assignment in it, which means Friday, which means it'll probably be Monday. Is what's going to tweak it to Monday the 10th. Yes, sir.